it. Now it's time to write an equation. I know the two parts, the measure of angle RTM plus the measure of angle MTP. Where am I getting P from? I'm sorry. The measure of angle RTM plus the measure of angle MTD is going to equal, those two parts sum up to equal the whole, the measure of angle RTD. So plug in what you know. The measure of angle RTM is 40 degrees, plus we don't know the measure of angle MTD, so just leave that as such, is going to equal to the whole thing, in this case 65. Subtract 40 from both sides, and we're going to get that the measure of angle MTD is equal to 25 degrees. Now, part C is where it gets a little fun. Part C is where we have some expressions rather than these pretty whole numbers. So part C says that if H is in the interior of angle EFG, so I have H there, it says, well, let me draw that ray real quick. It says that the measure of angle EFH, so this guy right here, is 75 degrees. And it says that the measure of angle HFG, which is the other part, is 10x degrees. And it tells you that the whole thing, EFG, so I'm going to kind of do this just to make sure it's clear that I'm referring to the whole angle, is 20x minus 5. So I'm going to write my equation, part plus part equals whole. So I'm going to say that the measure of angle EFH plus the measure of angle HFG is equal to the whole thing. I'm running out of room. EFG. Let's plug in my values. That means 75 plus 10x is equal to 20x minus 5. From there, it's just simple algebra. When you move all your constants to one side and your terms with variables to the other, you'll get 80 is equal to 10x, divide by 10, and x is going to equal 8. But it's not all that they asked us. They told us to solve for the variable x equals 8, but also they want to know the measure of angle HFG. Well, HFG, that angle is currently, the measure is being represented by 10 times x. So if x is 8, that means its measurement is 80 degrees. Remember that variables don't have units. They don't have units, but measurements and lengths and areas and so on and so forth, those definitely do. Part D says lines DB, so that's this guy right here, and EC, so these two lines intersect at point F. That's important that you know that they're a straight line, because then you know that they are a straight angle. It is, the measure of those is 180 degrees. So that's important that they tell you they are lines. It says if the measure of angle BFC, so this guy right here, is 44 degrees, and the measure of angle AFB is 61 degrees, then, and we've got a bunch of angles to figure out. The first one is the measure of angle AFC, so it's this guy right here. Well, if we use angle addition postulate, part plus part equals the whole thing, then we can simply add up these two measurements. Don't forget your units. We can add up these two measurements and get that the measure of angle AFC is 105 degrees. It then asks for us, I'm trying to get a different pen, here we go. And then it asks us to find the measure of AFE, so that's this guy right here. So now we're looking for this green angle. Well, we just figured out that this whole angle was 105. So the angle we just found, AFC, this obtuse that has the measure of 105, and the green angle that we're currently trying to find, that is a linear pair. Therefore, they are supplementary. So these two angles must add up to be 180 degrees, making this one 75. So the measure of angle AFE is 75 degrees. The last one it tells us to look at is the measure of angle EFD. So it's this guy right here. There's one quick and easy way of finding out what the measure of this angle is, and that is recognizing that angle BFC and the one we're trying to find, those are vertical angles, and they are always congruent. And you have the same measure. So there you go. This one's kind of like a puzzle. You just got to slowly start putting the pieces together and keep using your knowledge of linear pair and vertical angles. And the new information that we have is the angle addition postulate. Moving on, it says the bisector of an angle. So we know what this term is, bisector. To bisect something means to cut it into two congruent parts. So when you're talking about an angle, a simple point can't do that. You need more. So the bisector of an angle is a ray that divides the angle into two congruent adjacent angles. Over here on the math tip, it just reminds you what adjacent angles are. There's three things that are true about them. Adjacent angles are coplanar angles that share a vertex and share a side, a ray, but no interior points. It also reminds you down here what it means to have congruent angles. Congruent angles have the same measure. So if over here, if we look at this diagram, it says, for example, if ray BD, which is right here, if ray BD bisects angle ABC, then that means these two parts are congruent. So then we can conclude that angle ABD is congruent to angle DBC. If that's the case, if the angles are congruent, congruence means same size, same shape. So if the angles have the same size, same shape, that means their measures, I'm going to change notation because I want to start talking about their measurement. So we add the M in front of the notation. Then we can say those are equal, because now we're talking about some numerical value like 62 degrees or whatever. So then we switch over to equality when we're talking about measurements. So let's go ahead and practice that. Item 6 says, given that ray AH bisects angle MAT, so I have my angle here, MAT. I know that's the whole. Well, ray AH bisects this. So I know that point H must be in the interior of this angle. So that when you create or when you draw AH, it forms two congruent angles. These arcs that I put in the interior of the angle, those are called congruency marks. It's just indicating that these two have the same measure. Congruent angles will have the same number of congruency arcs. So if this one had 2, then I would have to add that one to have 2. This one had 3, then this one would also have to have 3. So congruent angles have the same amount of congruency marks in them. So part A says, well, if the measure of angle MAT, the whole thing, is 70, then one part of that, the measure of angle MAH, would simply be half that. So 35 degrees. It says in part B, so same diagram, same situation, but just different numbers now. It says if the measure of angle HAT is equal to 80 degrees, so if this guy was 80 degrees, then what's the measure of the whole thing? Well, if this is 80 degrees, and this must be 80 degrees, therefore the whole thing would be 160 degrees. This is one of the perfect examples that I was talking about in class. This diagram, clearly, the measure of angle, literally what I've drawn, this angle is not 160 degrees. But don't ever go strictly based off of the diagram. Sometimes they're not drawn to scale. Go with your numbers, have confidence in your answers. So even though this doesn't look like 160 degrees, we know that that is the correct answer. If this is 80, this must be 80. Add them up to equal the whole. It's 160 degrees. Moving on to page 47. It says you can use definitions, postulates, and properties of algebra to determine the measures of angles. So we're going to use definitions like the definition of bisector, the definition of simply what an angle is. Postulates, we're going to use the angle addition postulate, and then we're going to use properties of geometry. Those are those properties which helped us solve those algebraic equations and write two-column proofs. Those are the substitution property and the division property of equality and the transitive property and so on and so forth. You need to set those to memory. You must know all of those. So this section here just gives us a big old example for us to work with. It says that if ray QP bisects angle DQL. So just from reading that, you need to understand what's happening in the diagram. So first draw your angle DQL. And it said that ray QP is bisecting it. So that means P is in the interior, but not just anywhere. It has to be in a certain point that will, when you draw ray QP, it bisects these two angles. So this guy is congruent to that guy. Their two angles are congruent, then their measures are equal. It tells us that the measurement of angle DQP is equal to 5x minus 7. The measurement of angle PQL is 11 plus 2x. Determine the measure of angle DQL, which is the whole thing. So here it is. This is an explanation of how you would go about this problem. If you want, it'd be probably an awesome idea to just cover that up and read this, make a diagram, label your diagram, set up an equation, solve for your variable, and then plug it back into your expressions. That'd be a really good idea, a really good practice, and then you can just check your answer here. But anyways, so it says, that because ray QP is the angle bisector of angle DQL, you know that the two parts are congruent. Angle DQP is congruent to angle PQL. And since those two angles are congruent, you also know that their measures are equal. So using the definition of angle bisector, we know that these two measures are equal. So there's your equation. That's the equation you set up. You don't know anything about the whole, so you can't say part plus part equals whole. What are you going to set it equal to? You don't know anything about it. So you have to revert to simply just stating them equal to each other, because they are. So I'm going to use the substitution property and plug in my values. 5x minus 7 is equal to 11 plus 2x, and then just solve using the algebraic properties. Now we get down to x is equal to 6. And so what we're going to do is we're going to take this value of 6, and then we're going to plug it back in to our expressions. And this is also a great way to check to see if you did it right, because when you plug x back into the two expressions, you should get the same value, because if they're congruent, then they have the same measure. So these two angles have the measure of 23 degrees. So it says by the angle addition postulate, we know that the whole angle, the measure of angle DQL, is equal to the two parts added up, the measure of angle DQP and the measure of angle PQL. So therefore, we're going to substitute in our values. The measure of angle DQL is equal to 23 plus 23, which is equal to 46. They drew a diagram here and labeled it, so on and so forth. So now what I want you to do is pause the video and try these on your own. Create your diagrams and label your diagrams, write your equation, and then solve your equation. So go ahead and pause the video and try part A and part B on your own. You need to practice and then check to see if you are doing it correctly. It won't do you any good if you just copy what I'm doing. You got to try it on your own.